All right. Good afternoon, everyone. I see a lot of ice cream going on. That's good. So you're well prepared for the talk. Personally, I'm super excited to see some large-scale threat hunting going on. I mean, how much larger can the scale get than like threat hunting in cloud environments? And with that, I hand it over to Nate Warfield, who also has the perfect name for cloud threat hunting, I'd say, right?
Thank you. All right, can everybody hear me? I can't tell if my mic's on. Good? Can you hear me in the back? Excellent, all right. So I am Nate Warfield. I work for Microsoft, and what I'm about to talk to you today on is how I hunt compromised VMs in Azure. A little bit about me. My day job, I'm a senior security program manager for the Microsoft Security Response Center, which is kind of a mouthful, but in a nutshell, what my job is to protect 1.2 billion people on the planet every single month. So yesterday, when all your Windows machines said, hey, you have updates to install, that was me and my team. You're welcome. I also have the honor of working the Windows kernel, Hyper-V, Windows networking, and everything in Azure from the metal to the virtual machine, which means that last year for me was a very busy year. I owned MS-1710, I owned Wannacry, I owned NotPetya, and most recently I owned this tiny little vulnerability in your processors that they called Spectre and Meltdown. Before I came to the MSRC, I spent about 18 years doing network engineering, 10 of those years for a very large load balancing company. I've been a hacker since I was about 12. My first hack was a bulletin board system so that I could download Wolfenstein 3D. Over 2,400 baud, which kind of dates me, if you will. I like to look at the internet of insecurable things, I call it, and I'm a hobbyist of radio hacking. I won't say I'm a radio hacker because I'm surrounded by some of the royalty of the radio hacking world here. If you do the social media stuff, there's my Twitter handle. Some of the code that I'm going to talk about today I post on GitHub because I fully believe in giving back to the tools and the community. So I think it's important as I go into this to sort of highlight some of the ways that things change, right? I spent, like I said, almost 20 years building networks for pretty much every cell phone company on the planet. I built a lot of the infrastructure for Microsoft before I worked there. And there's sort of a breakdown of there was a traditional networking mentality that I was sort of schooled in and I spent most of my career doing. And then this whole cloud thing came along and it really changed the game and in ways that I didn't expect. Right, so in the traditional world, the internet exposure was fairly restricted, right? We didn't just put everything on the internet. In fact, it was generally time-consuming and rather tricky to get things exposed to the internet. You know, you had to have an internet connection, you had to have a public IP address. There was all these things that made it harder to do really dumb stuff. Today with cloud networking, anybody who has a subscription access into your cloud can, in theory, deploy anything they want on the internet at any given time. And you may not really know about it, which is where some of these problems show up. The other thing that the traditional model had was you had all these layers of ACLs, you had segmentation, right? We learned from our mistakes. One of the hacks that I did, back in high school was I was one of the first kids that got a cable modem in my network, in my neighborhood. And I noticed very quickly when I pulled up Network Neighborhood in Windows 98 that I could see all my neighbors and see all their file shares. And so this got me thinking, and so I had talked to a friend that was going to a university 3,000 miles away from me, and I said, hey, can you run this ipconfig command for me and just send me what you see? So they send me back their IP address, their network mask, and lo and behold, this college had every single computer publicly connected to the internet with a routable IP address. So me being me, I plugged this into my Windows Network Neighborhood and rebooted because that's what you did with everything in Windows 98. And once I turned on my Network Neighborhood, 3 or 4 minutes later, I was able to browse the subnet of this person's college and see all of the computers connected to the university network, all of their open file shares, connect to whack machine name, $, enter a password, enter, and now I've got machine access and I can see whatever stuff they have. Then we learned from our mistakes, right? We changed this model and we put ACLs in place, we put segmentation in place. Today with cloud, what I've found, and I'm going to get into a little bit in a minute, is that the VMs are deploying with this predefined firewall policy, and you may not be aware what this thing is, and most of the clouds that I've looked at don't even make you review it before it turns on. The other thing that the old model had was you had dedicated teams of folks like me. You had your server guys, you had your network guys, you had your firewall guys, and usually there was some management somewhere that said, hey, what are you doing? Why do you need to put this on the internet? So there was a lot of checks and balances, and what's changed now with cloud is, like I said, anybody with a subscription access can fire up any VM they want, and now it's online, right? You've bypassed all of these checks and balances that were put in place to try to make this at least more thought go into this process. The other thing that I found is working in some system administration roles. Obviously now I mentioned I work for MSRC, we release patches every second Tuesday, was when you had your traditional network, you knew your server inventory. You knew what you had, you knew what you needed to patch, you knew where your Windows servers were, where your Oracle servers were, where your Linux machines were, and you generally had a team that was responsible for making sure these things were updated, whatever cadence you have. Today with cloud, if you spin up what we call an IaaS or infrastructure as a service VM, this thing may not be updated when you turn it on. And if you're not paying attention to what's being turned on in your subscription, you may not know that it's there, meaning you may not know that you need to patch it. And if you're letting maybe your sales folks or some DevOps guys just spin things up for a demo or spin things up so they can prototype a system, they may not know that they need to patch it, or they may be too busy building the new shiny to actually make sure this thing is updated. Once again, the server is being deployed from the ground up. This allowed you to have some control, right? I remember deploying Exchange and a bunch of other things, and we made sure that everything was filtered, everything was firewalled. We knew what we had, we knew what services were running, and specifically we turned off things that we didn't need. Today, what happens with the third-party IaaS, these cloud marketplaces, these cloud galleries, is a company out there will say, hey, we want to offer something in the Azure cloud. They'll build a VM, they'll upload it, they'll put a description, some branding, some imagery, and whatever mistakes they made when they put this in the gallery are going to be copy-pasted when you deploy this thing. So if they made some dumb decision, every single person that goes and deploys this thing out of this gallery is going to inherit all of their mistakes, right? And it's nothing that can't be solved, but people have this misconception that just because it's served out of Azure or served out of Amazon that we're watching every little thing and making sure that it's as secure as it can be. And that's a misconception that needs to at least be highlighted, which is why I'm here today. And then lastly, like I said, we only exposed the bare minimum, right? We didn't put anything on the internet that shouldn't be on the internet. We tried to put, when I deployed Exchange, I had OpenBSD servers in front of it so that, I didn't trust to put an Exchange server on the internet in 2001. That's madness. Today, NoSQL open to the internet, seems legit. So this has led us to 2017. Many of these here are attacks that I've tracked in Azure. Some of these things are stuff you've probably read about. I am not going to talk about the S3 bucket stuff because I feel like Chris Vickery is way better suited to talking about this than I am. Plus, honestly, I work for Microsoft. My job is to secure Azure, and I'm still trying to reverse engineer the Azure's version of the S3 bucket. So maybe next year I'll have something more interesting to talk about there. So how did this start? Last year, actually starting in about August of 2016, though, I noticed a blog post about somebody was going into Redis machines and dropping this crackit SSH key, which would then allow them to connect back an SSH in as root and compromise the machine. So that got me thinking, what are these things? I'd never heard of Redis at the time. And I looked, I ended up going and looking and saying, oh, this is this NoSQL thing. The quotes behind me are verbatim from the security pages of these different NoSQL solutions, right? They tell you in their security pages, don't put this on the internet. Don't allow untrusted users, like firewall this thing off. I mean, it's a database server for all intents and purposes, and it's one that generally doesn't have a password. So of course, what are people gonna do when you tell them not to do something? They're gonna put it on the internet. So to date, and what's interesting to note is these attack campaigns are ongoing. I mean, I found some stuff as recently as last week that were modifications of the original attack campaign, but things really kicked off in January of 2017 when people started going after unsecured Mongo databases. And what they were doing was they were ransomwaring these things. That's kind of a misnomer. They were just dropping the database and pulling a little Bobby Tables on the administrators. They leave a ransomware note with a Bitcoin address and say, hey, if you want your data back, send some Bitcoin here. If you were unfortunate or foolish enough to send the Bitcoin, you're not going to get your data back. They didn't preserve any of it. Worldwide, I think the number was close to 180,000 machines that had this happen to them. What was interesting is when I was in the middle of tracking this, a little brew pub that's in Redmond that we would go for lunch, they were very flashy about this reader board that they had with like live updated tweets about their beers and all of this stuff. So we go in there one day and all their machines are blank. And I'm asking the woman, I'm like, what's going on with that? Like, why is that thing dead? And she's like, oh, I don't know. Our IT guy said we had some database corruption thing happen, and they're in the middle of restoring it, and we don't know. And it took about a week before they had this thing back online, it was interesting to see the real world impact of something that I'd just been sort of tracking as this, okay, these are nameless IPs and machines being compromised, and also I was like, wait, but I don't know what beers are on Nitro today. Like, how am I supposed to order a beer with lunch if I can't see your reader board? And it was very funny to see it hit so close to home. In Azure, I found this number, it's about 2,800 as of today, machines or third-party VMs that have been compromised by this type of an attack. And like I said, this is ongoing. I do this, I should have mentioned, I forgot to mention in the beginning that everything I'm talking about, this is what I do in my spare time. This isn't actually my job. I just really enjoy tracking the bad guys, and I protect Azure from the ground up as my job, but I also like to protect Azure sort of from the internet facing in, which is why I do what I do. So how do I find this stuff? As you might imagine, Microsoft owns a couple of IP addresses. I think if you look at Aaron, we actually are allocated something like 21.7 million IPs are owned by Microsoft all up. At any given time, there's about 1.6 million that are open on the internet and serving some sort of content, some sort of services, either for Microsoft ourselves or for our customers of Azure. If you've ever port scanned a network, you'll know that port scanning 1.6 million IP addresses takes a fairly long time. And the other thing that's interesting with the NoSQL infections is that while most of these database solutions tell you not to put it on the internet, tell you not to deploy it without firewalls, there are ways to secure this, right? With Mongo, you can enable a password, you can require some level of authentication. So just because a port is open, it doesn't necessarily mean this database has been compromised. The other fun thing about this is all of these NoSQL solutions, of course, run on a different port. So were I to go and port scan 1.6 million IP addresses for Mongo, I'd have to go do the exact same thing for Redis, I'd have to go do the exact same thing for Elastic, which doesn't really enable me to be quick about hunting threats. What I ended up doing about, I think it was after the second attack campaign that I saw, I just went to Wikipedia and I said, okay, well, tell me every single NoSQL solution that's been made and let me find all of the ports and let me start proactively looking at this stuff, because I'm not a real big believer in coincidence, so once I saw 2 of them happen, I'm like, this is what's going on. And attackers have realized this is just an easy way to try to make some money. They're going to hit every single one that's out there. And I was right. The only way that I could tell these things have been compromised was I needed to look at these databases, right? They would go in, they'd Bobby tables them, and then they would create another database, and it was usually something like DB dropped or send Bitcoin or a few other much more colorful things that I won't say out loud since I think I'm being recorded. But yeah, there was the only way to tell that these things have been compromised. I use Showdown for this, as you probably would have guessed. We do have an in-house solution that we can use to port scan our networks if we need to, but it's very much reactive, right? If we find out there's something going on, we can go and essentially just nmap or mass scan the entire network. So when I'm trying to track a threat that's evolving and it's happening in real time, I don't really want to go and say, hey guys, can I use the port scanning machine or network again so I can look for this stuff? And even if I could, I'm not really able to, I'm not going to get the database names that I need. Showdown, of course, has all this stuff. When we had I think it was during Wannacry, we had our team did a port scan of our networks, and they were like, no, there's no way that Showdown knows what our network space looks like. They're like, that's not our system, we didn't build it. So I said, okay, give me the data you have, and let's compare it to the data I have. And it was accurate to under 1%. The difference was I had it in 8 minutes, and it took them 12 hours. So make of that what you will. The other thing I like is that I got a lot of metadata, right? I'm not just doing a port scan for Mongo, right? I'm seeing, okay, here's an IP that has Mongo, but maybe it has some other things on it. And it gives me organizational information, the time that it was scanned, like all of the rich information that I have from Showdown, and I'm a big fan of it. And plus, most importantly, it gives me database names. And then the final part is all of this data, once I figure out what I'm looking for, I can dump this all out in a JSON file and make some really cool, tooling out of it, which I'm going to get to in a second. So as we started to remediate this for our customers, the response that we got from a lot of folks was like, wait a second, I didn't put Mongo on the internet. And they were like, no, I have a security team. We wouldn't actually do that, which led me to start thinking, well, that's a good point. There's 100,000+ people on the internet that have had this happen to them. Do I really think that 100,000+ people made the same like boneheaded mistake and said, okay, let's just put Mongo on the internet and let's not have a password and let's leave it open for everybody? Like that doesn't make a lot of sense. So I started digging into what's called the network security group. And this is the firewall that comes with your third-party IaaS image when you deploy it out of the Azure Gallery. This is something that is hard-coded by the company that builds this VM and uploads it to Azure. Part of the upload process, they say, okay, what ports do you want to have open by default when the customer spins this thing up? This is something you can change. There's a setting, there's a page as you go to deploy your IaaS VM that will say, okay, network security group. The thing that I'm kind of annoyed by is it says optional. It's not something we're actually going to make you look at before you turn the VM on. So you can just kind of click through the EULA, take whatever the manufacturer chose, and hold your breath and hope that it was okay. So touching on the whole, you only expose the minimum stuff that you need to the internet. Now, with a cloud network, it's different than your old traditional network, right? You would deploy something in your traditional network. You usually had a management-backed network that you could get in. You could do whatever you needed to do. Maybe you had dual home servers. Cloud makes that a little more difficult. So I will begrudgingly accept that you need to at least open a management port to your VMs, right? Whether it's SSH, maybe it's RDP, but that's fine. And in enumerating everything that the Azure Gallery serves up, I've said, okay, well, 46% of these things expose ports by default, a port, at least one, which is not as bad as I was expecting. I was thinking that maybe like 90% of all of the VMs out there or these IaaS images would expose something. What was more disturbing was that of those, 96% of them expose more than just a management port. The worst offender that I've found, as soon as you turn this VM on, it will open up 83 ports to the internet. Now, unfortunately, it's provided by a company who requires me to buy a very expensive license, so I can't actually turn the thing on and see if there's anything listening. But some of the other things I found that were a little disturbing was some VMs that would open up port ranges, including, and I ask you not when I say ports 135 to 137. And if you're an old school networking guy, you're like, what? Is that NetBIOS? Like, it's absolutely NetBIOS. There's a ridiculous amount of things people are just saying, just put it out on the internet for anybody. Across all the images in Azure, these third-party IaaS images, there's 562 unique different ports or combinations thereof that get exposed. Like I said, this is what I do in my spare time, so it's not like I can go pen test every single one or even figure out what's listening on some of these random, weird, high-numbered ports. But it was a little disturbing to see that, we spent a lot of time at Microsoft trying to make Azure secure, touting the security, and then there's this whole side channel where customers may be deploying stuff, and it's somewhat out of our control. So to be fair, Azure's not the only cloud that does this. As I was looking last year, I found that it was let me not get ahead of myself here. Amazon does the same thing. They just call this the Amazon Marketplace image, but it's essentially their third-party IaaS image. And it's, for all intents and purposes, exactly what an Azure Gallery image is. Now, AWS doesn't allow me to enumerate their firewall configs from the vendors. And I've had a few people, as I've done this talk, have said, no, that's not how AWS works. AWS doesn't deploy with default firewalls. Yeah, they do. To head off some of the that's BS comments that I get, I went and looked it up, and in fact, I've talked with folks that work for AWS, and they're like, "Oh, I guess we do that. That's suboptimal." So, in the interest of trying to just secure customers around the world, I've got an open dialogue with AWS right now, and I'm working on getting a feature request added so that I can enumerate all of their third-party IaaS stuff the way I do with Azure, and give them an idea of like, well, here's, because I've already told them this is what I see on our side. I'm pretty sure you guys are going to see the same thing on your side, and like I said, maybe next year I'll have some actual hard data to back up what their firewall config stuff looks like. It's interesting to note that Amazon, having been around for longer than Azure, has 5 times as many of these third-party IaaS images in their marketplace. And as I said, this is what appears to be a systemic problem. When I was looking at all of this stuff, Azure, Amazon, Alibaba Cloud, DigitalOcean, Rackspace, like all of your big guys, pretty much anybody that has a third-party IaaS gallery marketplace offering is having the same issue. So it's not just the 2 biggest guys. Google Cloud actually doesn't have as much of an issue, but when I go and look at them, they don't offer nearly as many images as you can to deploy as AWS and Azure. So in the interest of giving back and making use of this wonderful Showdown tool, I had the pleasure of meeting John, who built Showdown about a year ago, and we were talking about, what would be cool is instead of me having to do the same process over and over again, because like most hackers, I'm lazy, and if I don't have to do something twice, I'll just write software to do it. So I said, hey, dude, we should just have something that lets you automatically tag all of these things in Showdown and figure out which machines have been compromised. And instead of me looking for, okay, here's a Mongo campaign, here's one database name, I'll just download every single open database on every single NoSQL solution on the planet and go through them and build a master list of, I think it's like 80 of them right now that have been used in these attack campaigns, and just put it in Showdown. And so he said, sure, you write the code, I'll put it in Showdown. So that's what I did. So he added it back in December, and this thing runs constantly. As it scans, it processes databases, it runs against this code. As I find new attack campaigns, I send him new information, he puts it up there and he has time. And as of last week, there's still 22,000 machines out there that are having this happen. So over a year after this first started, there's still a ton of these things that are still popped out there. Whether they are machines that have been compromised for a year, maybe they're new deployments that have been compromised since then. A funny thing that we found when we were tracking this down in Azure is we came across a few machines that had the database dropped and a Bitcoin address put in. And then between when we found it and when we got it remediated, somebody came in and they changed the wallet address. They left the node, they left the database alone, but they just said, you know what, actually I want the wallet, I want that money. I'm not really supposed to connect into people's machines and look at stuff, so I haven't gone so far as figuring out what all the wallet addresses are and how much money they made off this campaign. But it was just funny to realize, okay, there's guys out there that are like, I'm too lazy to actually write the code to own the database, but I'm not that lazy that I can't just fix the wallet address and try to make some money out of it. Because I don't work for Showdown, and this tag compromise requires you to have not expensive for what it provides you, but it requires you to have a Showdown enterprise license. So I put the Python script that I wrote, it's up on GitHub. You just download a JSON export from Showdown, you run the Python script against the file, and it'll spit out the IP addresses, what type of database product, and the name of the database, or the name of the compromised database that they dropped in there. So I'm going to kind of change gears a little bit. This was something that I got to do right before I flew out from Seattle last week. I don't want to just be gloom and doom of like, here's how everything's just screwed up and everybody's owned. So this is, I felt, a fun exercise, right? Last week, this XMail Server, there was a remote code execution that came out for it. And I do this pretty frequently where I'll just sit there and I'm sort of a InfoSec addict, so I read RSS feeds and sort of the Twitter echo chamber is one of the panes that I've always got up. So I saw this thing come through, and I'm like, all right, let's see how many we have. So at the time, I did a quick search, and we had like 1,237 VMs in Azure running XMail Server, right? Like most of these RCEs, it's going to be against a specific version. So I'm like, all right, well, I don't really want to dig too far in the UI because I don't like GUIs. I'm a command line dude. So the first step I do is just download. Okay, show me everything that's product to XM and organization of Microsoft. there's a feature in Showdown that I don't think a lot of people realize. It's called CPE, or the Common Platform Enumeration Field, and this is a piece of metadata that I mentioned earlier that I've used to, you can identify WordPress versions, you can identify some web server versions, and in this instance I could identify which version of this XMail server was running. So once I had the download file, I'm like, okay, Showdown parse, give me the IP address, give me the CPE information. And I was actually putting this slide together last night, so these are, like, as of yesterday, some people that are still vulnerable to it. But what it allowed me to do is say, okay, the version that was fixed, I believe, was 4.90_1. So I could just do an inverse grep and say, okay, here's all the stuff that's not patched, 1,220 of these things, send it over to our SOC. It took me 5 minutes to do this. Right, an attack threshold of 1.6 million IPs, narrowed down to 1,200, narrowed down to exactly the ones that are running the insecure version. The SOC knew about it before they'd even seen the blog post. So I was like, they're like, oh, thank you. Now what do we do? I'm like, your job. They absolutely love me because I lob these grenades to them. I'm like, look, there's vulnerable stuff. This isn't my job. It's your job. But at the end of the day, they do thank me. I drove them nuts at first, but they're very appreciative because we're just making customers more secure. So something else I found that was a surprise to me was these third-party IaaS images. They have these descriptions that come with them, right? Part of the thing when you go to when a company goes to set these things up, they upload the VM. They can type in a description. They can add their company logo, et cetera, and they can also put in default creds. Well, now this was I don't want to shame the company, but they sell a secured version of a bunch of different software. And as I did a very, very basic thing of if the description contains username and the description contains password, flag it. And then I went and looked at them more closely, and that's not exactly the password, but it's basically the password. And it just says a note of, this is the password for your MySQL instance. When you turn it on, please make sure you change it after you spin up the VM, right? And that's because users are always going to change the passwords after they spin up the VM. And then, of course, I looked and said, well, it's just MySQL, right? Now, yeah, it's just MySQL, SQL. There was some Kubernetes things. There's a few other things that people had just hard-coded creds in there. It's not like there's a lot of MySQL servers on the internet. It's these are not Microsoft. These are just globally. But I think Microsoft, we've got 20 or 30,000 database servers that are pointing at the internet at any given time. So this is something that might be a little creepy. I was talking with some folks. And what I did about a year ago when I was looking at this stuff, I said, you know what? Let me try to get ahead of these. I was surprised that I'd never heard of NoSQL, but it's like I'd been out of that world for a while. So I said, okay, let me build a database that pulls down to the top 200 open ports against Azure and a bunch of other clouds in a bunch of countries, and does it every single day, puts it in an internet-facing MongoDB, and I can look at it and build statistical trends of stuff that's, I'm looking for lines that start to go up and, up and to the left of something that's the new flavor of the month. And I came across this thing called MQTT. MQTT is a mosquito. It's a brokering message server thing that I'd never heard of. And then I started digging around and learned that this is some sort of a thing that's really popular with IoT. Apparently Facebook Messenger also uses this. And there's a whole bunch of other folks that deploy this in one way or another. Azure and AWS also have MQTT offerings that you can set up for there. I think Azure's one is the Azure MQ server, and AWS is like Amazon IoT broker or something like that. The interesting thing was to find that in the last year, the internet exposure of these things has gone up by 25%. So it's obviously something that people are thinking is a really cool technology. They should start using it. And as I started digging into what are people using this for, I came across this solution called OwnTracks. OwnTracks is a piece of software that, and this is not to shame them, but it's something when I look at people not thinking about what they're putting on the internet and they're not thinking about what they're exposing, I looked at this thing and I'm like, that's weird. As I started looking at the device names, which I redacted because I did this last night, some of these things look kind of strange, like a Lenovo, Huawei, like it sounds like laptops, maybe cell phones, and turns out it is. So with their client, I can connect to one of these servers and say, hey, what if all these publishing information come back for me, right? So what this is showing you is it's giving me a TID, forget what the ACC stands for, but I've got battery time, it's got a connection flag, and then I've got latitude and longitude of somebody's cell phone in real time. Yesterday afternoon when I put this slide together, that's where this poor user was. Last night I got back to my hotel room and I was like, I wonder if this is actually real time or maybe I'm just putting together the pieces in the wrong order. No. They moved by about a couple of blocks. And this is someone in the Czech Republic. If they see this, I'm sorry, I'm not trying to send any creepy people to your house. I'm trying to illustrate highlight a point that this is the type of stuff people are putting online, right? This software is it's an open source thing. It's given, and they said, okay, you've got a server that you can set up. They have a humongous page about how to secure it, and they go into the details of that. The Mosquito protocol, it's not by default. It doesn't use the authentication by default. So they say, make sure you secure this, or make sure that you put this behind a firewall, et cetera, et cetera. And it also comes with a mobile client. So yeah, you put it on your phone, and then at a certain amount of time, this thing just says, hey, here I am, here I am, here I am. And then people like me can find you on the internet and figure out, where you're going, which is a little disturbing. So I'm going to change gears here. As I mentioned, I worked MS 1710, and these shadow brokers guys were a pain in my ass, I'm not going to lie. 1 year and 1 day ago, we patched the vulnerability that caused Wannacry. And I don't want to go too ad nauseum into details about it, but it's something worth kind of covering. As most people know, this unnamed agency built this really, really cool SMB v1 exploit, and it's fantastic. I get to see a lot of exploits working for the MSRC, and this is one of the cooler ones. Even the guys that took it apart were like, wow, this is impressive stuff. Then, as you would when you build a really cool SMB exploit, you put it in your Metasploit clone. As most people don't like to do, then you lose control of this tool, right? But at least this is a secret spy agency, and we don't actually know who built it. As I mentioned, we patched this in March, which, coming from somebody who spent the better part of 25 years in technology, if you told me 15 years ago that one of the worst 0 days ever built was going to be patched a month before it was on the internet by Microsoft of all companies, I would have been like, nah, dude, no. So the day that this came out, the day that the shadow brokers dropped their O-Day and released their password to the equation group tar file, I got in, the first thing I did was see it, pop it open on a VM, and just like, oh, I need to call a few people, like this is going to be big. And we spent all day, it was all hands on deck, all of our top reversers, all of our top exploit guys. We looked at this stuff from 6 a.m. in the morning Pacific time till 8 or 9 o'clock at night. And what was cool was that we could say, hey, we already fixed all this stuff. We fixed this stuff 31 days ago. The internet's fine. We got ahead of this. Good job. Pat ourselves on the back. But at the end of the day, we're also like, well, nobody puts SMB on the internet, especially not with Windows, right? I mean, that's just madness. The other funny thing the interesting thing about this was, like any good operator, when you've got this really cool 0 day, the more times you send this thing over a network, the more chance you have of somebody picking it up, right? I mean, most of us we all know of the companies that build these IDS systems and these systems that are trying to protect our users. So if you're smart, you're not going to burn your O-Days always, 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 because it takes a long time to build something this good. And you don't know, maybe the night shift guy popped the machine you were looking for. So they built this thing called double pulsar. And most people know what it is, but it was a way of just sort of doing a knock-knock and seeing if anybody knocked back, right? It used this weird undocumented SMB error code. You'd do a session setup, you'd send this weird command that was not implemented, and every SMB server will respond with an error, but if you'd been implanted with double pulsar, meaning that you'd had the exploit used against you, you'd respond with a different error code. It was like 0x51 versus 0x52, which most people looking at Wireshark are barely even going to notice the difference. The thing that was funny about that made this challenging when it came out, of course I was like, okay, let me go see, let me bust out my Showdown food, let me go see if I can find anybody that's been owned, and I very quickly realized, there's actually no indication of compromise. At the time, we had 14,000 odd IPs that had SMB open, and because I couldn't look for a database name, there was no DB dropped or pwned by the secret spy agency that I will not name. It wasn't like Showdown was going to give me any information. Fortunately, some very nice folks from, I believe it was NCC Group, took it upon themselves to write a Python script that did all the stuff that I'm not good at doing and would set up the session, send the thing, return the command, and it would let you know, okay, this thing has double pulsar on it or it doesn't. The other fun thing about this is when this came out, of course, every script kiddie on the planet's like, whoa, new exploit kit, let me just blast this thing at the internet and see what stuff I can pwn, right? I mean, it's like you could just give a monkey an AK-47 and let them loose. So, yeah, you've all dealt with script kiddies, you know how they are. So this is one of those, okay, well, it's a bad thing, but at the same time, I looked at it as, this could be a blessing and a curse, right? It sucks that these kids are going to just like, I don't understand what this thing is, but I'm just going to spray it across the network. But for me, what I thought was, thank you for letting me know how many unpatched machines I have out there, right? So if you just spray this thing and you get through stage 2, once it's been infected with double pulsar, now I know sort of what my risk rate, and right, how many people have VMs running in Azure that didn't install the patches. So I manually scanned everything, downloaded the thing, put a big bash loop together, let it run overnight, looking for double pulsar, and what I found, less than 50 machines out of 14,000 had been infected with this thing, which maybe foolishly I thought, okay, well that must mean that everybody patched, and coming from the guys that do Patch Tuesday, I'm like, sweet, mission accomplished. Like, they all did what we tell them to do, and they installed the patches, and this isn't going to be as big of a thing as we thought it was, right? I mean, once again, we're ahead of the problem, now we're really ahead of the problem. What do we have to worry about? Well, 28 days exactly after the shadow brokers dropped their O-Day, Wannacry hit. I don't know what it is about folks, these miscreants, but they love to do this on a Friday. Maybe they know everybody's at the pub. Maybe they know that it's spring, you know, half the world is probably like, oh, it's a beautiful day, I'm going to take the day off. Nah, they're just going to ruin our entire day. So when this hit, Azure at the time, remember that database I told you I built? So I can pull exact numbers out of any day in the last year. Azure's exposed SMB was 14,000 and change virtual machines that had a port 445. Now, I wasn't pulling the other details like what version of SMB and whether authentication was enabled. This was just SMB all up. Wannacry only went after the MS-1710 unpatched systems, so you know it's like, all right, it's not that big of a deal. You know that maybe this isn't going to be a big thing. Obviously, there's no way Showdown's going to catch it because it's going to reboot your machine and the thing's not going to work, so there's nothing to scan. The initial infection, everybody's, at this point I believe agrees, was an internet exposed SMB port, imagine that. Somewhere in Southeast Asia, whether they were testing it, whether there was like weapons test, let's see how effective this thing is, we'll probably never know. Obviously it was effective, 230,000 and change machines were hit with this thing across a large portion of the planet. And this was a fairly low-tech attack, right? I mean, you've probably all dealt with pretty high-grade attackers or APTs. I hate using that term because it's kind of a buzzword, but it's true. This was just, in my opinion, some script kiddies wrapped some code around an exploit they didn't understand and said, let's see what it does, and maybe we can make some coins in the process. The other thing that was interesting to note is that it only propagated via this Eternal Blue MS-1710 exploit. And I know this is a little bit repeat, you've all heard about this a lot, but I'm going to get to why I'm bringing this up in a second. 6 weeks after Wannacry, not fetch a hit. I think they might have been nice and not drop this on a Friday. I think this was middle of the week, if I remember correctly. At the time, Azure's exposed SMB had gone up by 13%. Now, I don't know about you, but I would think that after the shadow brokers dropped it and after Wannacry hit, people would have been like, do I have any SMB on the internet? Because if I do, maybe I should fix that. I thought the same thing. In fact, I had to go double check my numbers because the day it happened, I did the same thing. They said, the SOC says, hey, Nate, how many things are out there with SMB open? And I pulled the numbers and I didn't really think anything of it until I started putting these slides together. And I'm like, I wonder what the difference was. How much did we get better from Wannacry? And then I'm like, oh shit, we didn't get better. We actually got worse. So this is an interesting thing, and I'm still trying to figure out why this is, right? Is this just extra customers turning on VMs? Is this people that just didn't get the memo? This is a very prime example of what we deal with at Microsoft all the time. We spend so much time trying to give people the tools, give them the patches, but at the end of the day, we can't save people from themselves, right? I mean, this is arguably one of the worst cyber weapons that's come out in the last few years, and the exposure had gone up between Weapon 1 and Weapon 2. This, unlike Wannacry, wasn't just a worm. This was a thing that they did against the Ukraine. The initial infection, they backdoored MEDocs. They put some Trojans in there, and they said, hey, guys, it's Patch Thursday. Update MEDocs. And down comes the ransomware. My theory on why this thing was escaped the Ukraine was what I really am going to get to in a second, point-to-point VPN links, right? This software is very specific. It's a very targeted use purpose, right? There's not, I'm from the US, most companies in the US aren't going to run this software, right? We use TurboTax or whatever other products that we have there. But it escaped Ukraine, right? Maersk took a humongous hit with this thing. I think they were down for months. The numbers were something like 50,000 workstations had to get wiped and reinstalled. They had like 10,000 servers that had to get wiped and reinstalled. And this was a high-tech thing. This was not just some script kiddies putting a Python script or some basic code around it and then just lobbing it on the internet. And I say it was a high-tech weapon because it had multiple movement methods, right? Instead of just saying, okay, well, let's only look for unpatched machines, this one had our old friend Mimikatz, this has psexec, and they had WMIC, and then if all else failed, it could use MS-1710. And what I think is important to highlight here is this multiple lateral movement method. And I think this is something that we'll start to see happening more and more, right? As businesses get better at patching, as people get more, just more aware of the risks in their network, especially, if you use Windows 10 for the latest security updates, it's a lot easier to stay up to date. However, that wouldn't matter here, right? If you had one machine that was exposed, it's going to just Mimikatz away around your network, and it's going to take out everything that's 100% patched. It doesn't matter because you built a bank, and then you put a screen door on the back, right? Which brings me to my next point. When you're deploying things in Azure or any other cloud, you need to remember that IaaS security is 100% your responsibility, right? You're basically paying for a cloud subscription, and you're using it the way you did your classic network. You're building infrastructure that we own the servers, we own the network, we own all these other parts, but what we're giving you is a platform, and you're spinning up VMs, and all of the challenges that you had back when you did classic networking are still there, right? You still have to patch, you still have to worry about all these things. And then there's this other fun thing about, anybody ever heard about Express Route or Direct Connect? Yeah? Me too. So these are the descriptions from both Microsoft and Amazon as to what these technologies are. If it sounds like a VPN, it's because it is. So this is why I bring up the Wannacry and the NotPetya thing, because if you've got a VPN connection into your cloud subscription and your sales guy is spinning up a server and you don't know it's there, like, guess what your sales guy just did? You just opened a back door into your network, right? And if you're not paying attention or if you're not auditing what you have in your IaaS infrastructure, well, that's going to be your problem. Which is one of these things that I've spoken to folks in the last couple months about this, and in fact, I've talked to a few people that run both. They're like, yep, we do dual cloud, we have AWS, we have Azure, we have Direct Connect and ExpressRoute, and they're like, the hardest thing to do is ACL off these point-to-point VPNs, right? If you deploy these stuff back when you were a classic networking guy, it was like, all right, I know my office here, I know my office there, only these two talk to each other, and nobody else is gonna get in. At least with Azure, if you want to pay the extra money for dedicated IP space, I know we sell it to you. If you aren't maybe fully vested in the cloud, or you didn't know that we offer this, and you have dynamic IP ranges that can change when you reboot a VM, well, there's a very large amount of IPs that can get exposed. And the most frightening thing I had was talking to a guy a couple months ago, and he's like, yeah, we don't really know how to figure out what our VMs are going to get, so we just allowed all of Azure's IP range into our network. I'm like, you did what? He's like, yeah, there's an XML file you guys published with all your IP space, and we got tired of the CEO calling up and saying he couldn't get to X, Y, or Z, so we just took that thing and just put the entire IP space into our firewall. I'm like, YOLO? Yeah, I definitely gave him some contact information. Like, there's a better way, trust me, like, don't do that. So it brings the point, right? If you're doing this and some folks think, oh, well, I have my network and it's my castle, and then I have my cloud and that's a different thing. If you're using point-to-point, it's not really any different, right? And the cloud is your network is the cloud, and as our technical fellow here, Mr. Jeffrey Snover, when he says we spend a lot of time and money, like, he's not kidding, we're Microsoft. We spend a ton of money securing everything we can for Azure, right? I mean, we are building a platform for customers that have trusted us since Windows 3.1 was still a thing. So we are doing everything we can to secure Azure from the level that we can, but at the end of the day, when you're deploying third-party IaaS, like, that's your responsibility. And you need to consider, do your IT policies on patching and access control and isolation and all of these other things, are these extending into your cloud, right? Like, don't treat the cloud as just, you know, that's somebody's little fiefdom and I'm the king of the castle, right? You need to consider it's two ways with IaaS. Now, I don't want to be too gloom and doom because, and I'm not a sales guy, I promise, we do have some solutions to make this easier for you. So, I mean, how many of you heard this? Patching causes downtime. I hate having to reboot my servers. I'd rather just wait for a worm to do it for me. Right? Patching does cause downtime. It's unavoidable until we figure out how to not reboot machines when we update the kernel. Or my cloud provider handles all my patching for me, right? We hear that every now and then. Yes and no. So this is some stuff I wasn't as familiar with because I'm old school and I don't really deploy a lot of stuff in the cloud. It's just like what I use as a platform for, I mean, all of my stuff is IaaS. But as it turns out, platform as a service and software as a service were designed to solve this problem of I still have to patch all my stuff even in the cloud, right? So there's this concept of a shared responsibility model. The easiest, right, and I've told people this a couple times now, if you don't need to run infrastructure as a service, like run SaaS, right? If you just need someplace to host your widget or your new shiny thing, and you don't have a bunch of sysadmins or a bunch of security dudes, just run SaaS. We will patch everything for you. You don't have to ever think about it. The infrastructure it runs on gets patched every single month. We make sure that it's secured. We're not going to let anybody. We're going to do everything we can. All of the stuff that Jeffrey Snover was talking about. If we spend this money and this time to keep you secure, you're taking advantage of it, right? If you're buying a cloud subscription, don't worry about patching it. The platform as a service is a little interesting. This is another. The shared responsibility is that you need to have some thought and planning in how you deploy. You can set up what I believe are called failure domains, or I'm not a sales guy, like I said. So the concept of a failure domain is similar to the old school sort of load balancing idea, right? You say, okay, well, I have this platform, I have my resources, and you can tell Microsoft, say, through a control panel or widget thing, saying, yeah, when you need to patch, these are the ones to take down first, or this is how to move my load from one system to the other, patch this thing, move the load back, patch the other thing. So we still handle the patching for you, but to deploy this, you actually have to think it through a little bit more. So we do this to try to keep you secure. This is something that we can help you not take this load off of you and your system administration. The thing that we see with cloud is, right, people say, oh, it's so easy to be agile and we can do all this stuff really fast because we don't need to have a network team, we don't need to have a server team and all these other things. Well, when you get rid of all those teams, now it's your job to be the network guy, the server guy, the router guy, the firewall guy, right? So take advantage of what Microsoft, and I'm sure Amazon sells this as well. Take advantage of the things that we have to help take that load off you. So the other thing that I want to highlight is that cloud marketplaces need to be considered supply chains, right? As we've seen in the last year, especially working for Microsoft, we had to deal with this as well, especially with CCleaner, is that attackers are getting smarter, right? They're realizing your people are spending tons of money on InfoSec. It's a lot harder to compromise a big company. What it's not hard to do is compromise a small company that makes a really cool tool that everybody likes to use. With CCleaner, with I think Notepad++, this was true. We use both of those tools in Microsoft. Obviously we do, because CCleaner had our internal networks as places to look for, right? They knew build networks inside of Microsoft to say, hey, if you see these domains, get a stage 2 payload because there's going to be interesting shit in there. The Google Play Store has been plagued with this type of stuff, right? People set up an app and it looks fine, it gets through review, and then once it's on your phone, it's like, hey, let's mine some Monero. Cloud marketplaces are a perfect target, right? There's tons of resources. The targets that are going to be deploying in here are fairly high value, right? I mean, it's big companies, lots of money, very juicy stuff maybe inside their networks. the validation of these third-party IaaS images is fairly minimal, right? You set up for, say, marketplace seller account, you go through some paperwork, and then there you go, publish your third-party IaaS, and we trust the companies that publish it to be maintaining the security of these things. As a result, they can be very, very old. I did some numbers, as I enumerated everything in Azure, and then with AWS, one of the only things I could get was the age of their IaaS images. With Azure, the images that we sell you from Microsoft, right, Windows Server and all those things, every 28 days or so, they get updated. The rest, your average age, 4 months. You go to AWS, I only looked at their marketplace. I didn't look at the Amazon official images, which I'm sure are much more frequently updated. But their marketplace stuff, on average, is 700 days old, right? That's 2 years of vulnerabilities that are going to be just ready to go as soon as you turn this thing on, right? I mean, nothing says you can't update it, but like I said, people think, oh, well, I got it from these cloud guys. It's secure when I turn it on. Wrong. Which brings me to my next point. 2018 is becoming the year of the crypto miner, right? Folks have realized that ransomware is very, very, it doesn't make a lot of money, it's very noisy, it kills the host, and it doesn't, I mean, I guess the guys from Wannacry made some money, but the NoSQL folks, as far as we can tell, didn't make much. So they switched campaigns. Actually, 2 or 3 weeks ago, I saw Trend Micro posted this thing, and I went and looked on Showdown, found out there was 1,700 machines worldwide that had this new Monero DB thing dropped in and were mining Monero currency. There's about 80 something of them that were in Azure. So I've already fixed the code, I've already sent it to Showdown, he's already tagging it. But people are going after open S3 buckets. I know I promised I wouldn't talk about it, but I mean, a couple weeks ago, the LA Times was mining Monero currency. Somebody found an S3 bucket, they dropped a script in there, everybody that went to go get their news was mining cryptocurrency for whomever. And people are going to use this ability to now reach out and steal from you is being rampant, right? I mean, historically, theft on the internet was intellectual property. You're pirating my music, you're pirating my MP3s, you're pirating my software. But today, I can actually go out, I could rack up a humongous electrical bill in your data center and mine currency for myself, right? At the end of the day, your power company's not going to be like, oh, no, bro, it's cool. Like, you didn't know you were compromised. No, they're going to be like, no, dude, you ran an Oracle server at 100% CPU for a month. These dudes made $250,000, and I think it was 2 or 3 weeks mining Monero currency. I mean, that's where we're headed. And, all right, so for great justice, some closing things, because I think this is a problem, and to make the world a safer place, and I love that that's the theme of Troopers. Update your IaaS VMs immediately. There's no reason this stuff can't be just as secure as a PaaS or a SaaS or even your traditional network, but you just got to remember it takes extra steps. Review the firewall settings when you turn these things on, right? PaaS and SaaS are not going to really have a firewall setting. When you're deploying IaaS, there's a panel. I promise you there's a panel that has the firewall settings it's going to deploy with. Take a look at it, and if you don't understand it, ask your network guy or firewall guy, like, hey, Joe, is this a good idea? Because they're either going to be like, nah, it's fine, or they're going to be like, holy crap, please don't do that. For sensitive roles, for stuff that if your business is very, very sensitive, or you have stuff that's PII or really important data, I know Azure offers this. You can roll your own VM image, right? You build it up, you configure it, you secure it, you have it exactly the way you want. You can put it up there, it's only available to you, and you can say, okay, we're going to need 20 of these things. Your guys, whoever you say, okay, you have subscription access, you say, okay, we need more capacity, turn on only this one, right? You have oversight, you know how secure it is. Something that I'm working on as my own project is to bring some better visibility into Azure. So right now, the Azure Gallery team is working on exposing the age of these IaaS images to you. So sometime soon, when you go to turn one of these things on, it's going to tell you this VM image is this old, right? So at least you know what you're working with. We're also trying to figure out a way without interrupting people's business to make you look at the firewall before you spin this thing up. Right now you can click through it. My advice, we're trying to figure out the details because we're trying to not interrupt people's business, but at least make sure that they know the risk that they're getting when they turn it on. And the more interesting one that turns out they were working on is looking at these VMs and seeing what versions of these different solutions are on the VM, right? If you deploy an Elk stack, what version of Elastic and Logstash and Kibana comes with it? This will serve 2 purposes, right? If you know security, you'll be like, I know that there's an RCE out for that. Or the next time like a Shell Shock or a Harply comes out, At Azure, we can say, okay, select all from these VMs where version of this is vulnerable, and then we can immediately say, okay, stop letting people deploy those VMs. We reach out to the vendors, we say, you need to update all your stuff, or we're not going to let people spin up your things. And lastly, if you use Azure, again, I'm not a sales guy, it turns out Azure Security Center has a free tier thing where we'll take a look at what you're doing, we'll give you some recommendations on whether or not you're secure and best practices you can make. And of course, if you want to get more, you can always pay for it. But this is stuff that you can do today without having to pay anything extra. And with that, thank you very much. And if you have any questions,